Hello everyone, good morning. Welcome to this talk, Karmada project introduction and updates. I am Afan. I am a cloud security solutions engineer at AccuKnox, and I was also a CNCF mentee for Karmada. So imagine a scenario where you have to manage multiple Kubernetes clusters. You will be jumping off between different kube configs. You will be switching context for kubectl, and you'll be applying configurations repeatedly to multiple clusters. So it is a tedious and repetitive task to do, and there is no centralized way to manage your multi-cluster environment. And let's say if you are deploying same application to multiple Kubernetes clusters, you cannot make sure that your application is in sync with the other clusters. So here, Karmada solves all of these issues. Karmada is an open source CNCF incubating project, and it allows you to manage multiple clusters from a centralized environment. And here is the architecture of Karmada. Karmada can be installed on top of an existing Kubernetes cluster. And in the architecture, you can see that on the top part, we have Karmada control plane. And at the bottom, we have member clusters that Karmada will be managing. So the architecture pretty much resembles the Kubernetes control plane and worker node architecture, where we deploy workloads into the worker node using the Kubernetes control plane. And here we are using Karmada control plane to deploy and schedule our workloads into the member clusters, your multi-cluster environment. So the Karmada API server is built on top of the Kubernetes native APIs, so you can use kubectl, and kubectl will directly communicate with the Karmada API server, and you can run commands like kubectl apply, and you provide a configuration file, or you can use kubectl get deployments to get your workloads, and you can provide a cluster flag to get resources from a specific cluster. So here is how the deployment works. First you apply a vanilla Kubernetes config file. Let it be your deployment, your services, your config maps. So after deploying the Kubernetes manifest, you need a propagation policy. So basically, propagation policy is a configuration that defines where your resources should be deployed, like in which cluster. And you provide a propagation policy, you provide your manifest, and you deploy the workload. And optionally, you can also override some of the parameters from your workload file using the override policy. For example, let's say we have a cluster in some other region that we want to use some other container image for a container, or let's say you want to use a different storage class for a different cluster. You can do this by using the override policies. So when it comes to the scheduling, Karmada is very flexible. It allows you to schedule based on different parameters, like you can schedule your workloads based on the cluster names, labels, tension, and tolerations. And you can even use the resources like CPU, memory, and weight. So Karmada also have a failover mechanism. When a cluster goes down, it will gracefully migrate those resources to the healthy clusters without any interruption in the services. And another amazing feature that Karmada have is multi-cluster service discovery, which allows your workloads to communicate with the services that are deployed in another clusters. Here you can see we have a service in the cluster 2, and an application is deployed in the cluster 1, and that application is accessing the service. So it is Kubernetes native, and you can do cross-cluster service discovery using Karmada. And speaking about the community, we are a fast-growing community of nice people, and we have 700 plus contributors from 70 plus different companies. And yeah, thank you for being here. Thank you for your valuable time. If you enjoyed Karmada, give us a star at GitHub and join the community on Slack.